Well, let us consider some particular problems in equilibrium theory. First of all, a border equilibrium. What is the meaning of this border equilibrium? Let us trace our usual Azure box. This is the initial endowments. Trace our budget line. Remember, the budget line of consumer 2 continues below the basis of Azure box. Or suppose that this point you have tangency here and here. Look at this graphic. Consider the situation of consumer 1. Also for consumer 1, the budget constraint continues outside the Azure box. But note that the optimal point is represented by this D1 of P. What is the characteristic of this point? It's a border point in the sense that only one good is demanded. Only the first good is demanded, and the demand for the second good is equal to 0. In this sense, it's a border point because it is on the border of a non-negative orthant. For the consumer 2, remember that his budget line continues here. The optimal point is another time this. But in this case, the demand of both goods are positive. This is an equilibrium because there is a coincidence between the optimal points. But the characteristic of this equilibrium is that the equilibrium is on the border of the box. In other terms, the demand for one of the goods by the first consumer is null. This is an important result because this is a point, as we shall see, there is no equality, not necessarily equality, between the slopes of indifference curves. In other terms, it is not verified the usual condition of equalization of weighted marginal utilities. At this point, only the more general Kuhn-Tucker condition hold. You remember in the first part of the course by Pacini? Well, this is simply an extreme case. But, however, in this case, the equilibrium exists. The main point is the following. There are cases in which the equilibrium does not exist. Sure, I will show you 3 different cases of inexistence of equilibrium. The first is the most complex one. Suppose there are our usual 2 households, and the preference relation of the first household can be represented by a utility function like this: square root of x11 plus square root of x12. This is a constant elasticity of substitution utility function. While the utility function for the second consumer is equal to x21. Clearly, this is a very particular case, but let us study for a moment these two preference relations. Let us begin from the second. It's very simple. Only good one is relevant for consumer 2. Note that in the utility function of consumer 2, the quantity of good 2 x 2 does not appear. So, preferences of consumer 2 have this form. They're in different schools, sorry. There are straight lines parallel to the second coordinate. Utility increases obviously in this direction. Note that only the quantity of good one is relevant. Given the quantity of good one, every quantity of good 2 gives to the subject the same utility. This is the form of the preferences of a first subject. Clearly, these preferences are regular, obviously, because they are representable by means of a utility function, are convex, and are also monotone, but they are not strictly monotone. Because if you increase the quantity of good 2, given the quantity of good 1, nothing happens. The utility remains the same. Is it clear? Now let us represent the different schools of subject 1. They have this form. They have the usual form, but it is important to note that every difference curve touches both coordinate axes. It's a particular consequence of this functional form of codes. Is it clear? Finally, let us suppose that the initial endowment of subject 1 is 0, 1, while the initial endowment of subject 2 is 1, 0. In other terms, in the economy, there are in the whole available 1 unit of good 1, which is given to good household 2, and 1 unit of good 2, which is given to household 1. Let us represent this situation in an edger box. Where is the point omega? Here. Is this point. This particular allocation of goods, which, note, the subject 1 has 0 quantity of good 1 and 1 unit of good 2. Suppose that both the length of the edge boxes are clearly equal to 1. For subject 2, it is the contrary. The initial endowment contains 1 unit of good 1, but 0 units of good 2. Is it clear? Now, let us take any price system with all positive components. at R2 represent the positive orthant of a two-dimensional Euclidean space. So you have a common budget line like this. From the first part of the course, from Pacini first part, you know that with a constant elasticity of substitution, the demand by subject one of both goods is positive. So we have a point in which both positive components. Is it clear? But what is oh, sorry. This is the subject 2. No, va bene. Sorry. Okay. No, it is correct. Well, consider subject 2. It is as he has this particular form of preferences. So, for him, the quantity of good 2 is irrelevant. Only the quantity of good 1 is relevant. It does represent in this graphic the situation of subject 2. Omega is here, omega 2. 1 unit of good 1, 0 unit of good 2. Trace the budget line and you observe that the optimal point is simply the initial window. For every positive price system, our consumer 2 prefers to remain with his initial endowment. So its demand is simply this vector. Is it clear? But it is obvious that in this case there is no equilibrium, because the optimal point of subject 1 and subject 2 do not coincide. But we must consider also the case in which one of our two price systems is equal to 0. It is possible that equilibrium exists for a price system in which one of the components, one of the prices is equal to 0. It is impossible that both are equal to 0, of course, but it is possible, for example, that P1 is equal to 0, P2, for example, is equal to 0, and P1 is a positive number. But what happens in this particular case? What is the form of our true budget constraint? Consider, for example, subject 2. His initial endowment is this. Since the price of good 2 is 0, he can buy any quantity of good 2 without expenditure. So the budget constraint is like this. Substantially all the points on the left of this half line. But consider now the situation of subject 1. In this point there is his initial endowment, omega 1. Remember, omega 1 does not contain any quantity of good 1, but 1 unit of good 2. So it is here. The budget constraint of our subject, if the price of good 2 is equal to 0, coincides with this half line. Why? Because, for the same reason. Because good 2 is not, it is gratuitous, it's free. You can obtain any quantity of good 2 without any expenditure. So my budget constraint is this half line. But since, note, that you can move to higher and higher and higher in different schools, because all have this form, it is not possible to maximize utility. In this particular case, when one of the prices is equal to 0, there is no maximum utility for consumer 1. So, literally speaking, his demand, optimal demand bundle is not defined. For the consumer 2, there is no problem. Every point along with this alpha is indifferent to every other point. The problem is with consumer 1, because in this case, there is no definite solution to the problem of constrained maximization. I repeat, since good 2 is gratuitous, is free, you can increase the quantity of good 2 as you wish. But since good 2 has a positive marginal utility, utility increases without limit. And so there is no solution to the problem of constrained maximization. Same result holds if you suppose, on the contrary, that P2 is a positive number and P1 is equal to 0, because in this case both subjects could increase the quantity of good without limit, and so increase also their utilities. And so, in this case, the optimal point is not defined both for consumer 1 and consumer 2. So, both of these price systems cannot be equilibrium price systems. But, however, every other price system with all positive components, as you told before, is not an equilibrium, and so there is no equilibrium at all. In this case, equilibrium does not exist. What is the problem? With this case, substantially, the null prices, the behavior of a budget set when some price tends to 0. As we shall see rigorously afterwards, this is the fundamental problem. The fact that some prices can be equal to 0, and the fact that the initial endowments are not internal points to the non-negative ortant, because they are on the coordinate axis. Note, omega 2 is on the border of the non-negative ortant, but also omega 1 is on the border. The combination of these two particular situations produces inexistence of equilibrium. Moreover, note that in this case preferences are monotone. In the case of consumer 1, they are also strictly monotone. But in the case of consumer 2, they are only monotone, because any increase in good 2 given the quantity of good 1 does not produce any increase in utility. So these are the problems with this case. This is a traditional example, the simplest example of inexistence of equilibrium. Note that preferences are continuous, are represented by continuous utility functions. The problem does not arise from discontinuities. No, absolutely no, not discontinuity of preferences. Discontinuity of a budget constraint, as we shall see afterwards. Well, let us have another break.